Hi, let's get started with our new section. In this video, I want to talk about the data science and marketing. So, with the growing amount of data and applications of data science in marketing, we can easily find examples of the usage of data science in marketing efforts. Companies are starting to use data science to better understand customer behaviors and identify different customer segments based on their activity patterns. Many organizations also use machine learning to predict future customer behaviors, such as what items they are likely to purchase, which websites they are likely to visit, and who are likely to join. With endless use cases of data science for marketing, companies of all sizes can benefit use from using data science and machine learning for their marketing efforts. After this brief introductory video, we will learn how to apply data science and machine learning for individual marketing tasks. So as the amount of data available and gathered increases exponentially every year, and access to such valuable datasets become easier. Data science and machine learning have become an integral part of marketing. The applications of data science in marketing range from building insightful reports and dashboards to utilizing complicated machine learning algorithms to predict customer behaviors or engage customers with the products and contents. The trend in the trends in marketing in recent years have been toward more data-driven target marketing. So we will discuss some of the trends we see in the marketing industry. The first one is the rising importance of digital marketing. As people spend more time online than ever before, the importance and effectiveness of digital marketing have been rising with time. Lots of marketing activities are now happening on digital channels such as search engines, social network, emails, and websites. For example, Google Ads helps your brand to get more exposure to potential customers through its search engine, Gmail, or YouTube. We can easily customize your target audience to whom you want your advertisements to be shown. Facebook and Instagram are two of the well-known social networks where we can post your advertisement to reach your target customer. In the era of the internet, these marketing channels have become more cost-effective than traditional marketing channels such as television advertising. The second one is marketing analytics. Marketing analytics is a way of monitoring and analyzing the performance of marketing efforts. Not only does it help to understand how much sales and exposure you gain from marketing, but it also help you gain deeper insights into more individual level patterns and trends. In an e-commerce business, you can analyze and visualize the different types of segments of customer and which type of customer drives the revenue for your business the most with marketing analytics in media businesses. With marketing analytics, you can analyze which content attracts the user the most and what the trends in keyword search are. Marketing analytics also helps you to understand the cost effectiveness of your marketing campaigns by looking into the return on investment, which is the ROI. You can further optimize your future marketing campaign as the adoption and usage of marketing analytics rise. It's not difficult to find various software products for marketing analytics. The third one is personalized and target marketing. With the rising applications of data science and machine learning in marketing, another trend in marketing is individual level target marketing. Various organizations of different sizes utilize machine learning algorithms to learn from the user history data and apply different and specialized marketing strategy to smaller and more specific subgroups of their user base, which results in lower cost per acquisition and higher return on investment. So in retail businesses, many companies implement artificial intelligence and machine learning to predict which customers are more likely to purchase and which items they are going to buy from their stores. Using this prediction, they customize the marketing messages to each of their customer. Many media businesses also utilize artificial intelligence and machine learning to drive higher engagement from individual users to grow their user base. So the overall trend in marketing has been toward more data-driven and quantitative approaches. Companies of all sizes have been investing in marketing analytics and technologies more and more. So it's a time to talk about the descriptive versus explanatory versus predictive analysis. So as we work through the exercise and projects in the upcoming section, there are mainly three different types of analysis that we are going to conduct throughout this course: descriptive, descriptive, explanatory, and predictive analysis. So descriptive analysis is conducted to understand and describe the given dataset better. The purpose of this analysis is to quantitatively and statistically summarize the information that the data contain. For example, if you are conducting a descriptive analysis on a user purchase history data, you will be answering short questions as what is the best selling item, what were the month sales like in the past year, what is the average price of the item that are sold. Throughout this course, we will be conducting descriptive analysis, whether we introduce a new dataset, especially in key performance indicators and visualization. We will be discussing in more detail how to use descriptive analysis to analyze and compute key summary statistics as well as visualizing the analysis results. Now let's talk about the explanatory analysis. So when the purpose of descriptive analysis is to answer what and how from the data. Explanatory analysis is to answer why using the data. This type of analysis is typically conducted when you have a specific question that you want to answer. And the last one is predictive analysis. So this analysis is conducted when there is a specific future event that would like to predict. The purpose of this analysis is to build machine learning model that learn from the historical data and make predictions about events that will happen in the future. So it's a time to talk about the type of machine learning. So let's now discuss more about machine learning and machine learning algorithm. Broadly speaking, there are three types of machine learning algorithms. The first one is supervised learning, the second one is unsupervised learning, and the last one is reinforcement learning. So let's first learn how these different types of machine learning algorithms differ from each other. Now let's talk about the first one, which is supervised learning algorithms. So these algorithms are used when the prediction target or outcome is known. For example, if we want to use machine learning to predict who will make purchases in the next few days, then we will use the supervised learning algorithms. Here, the prediction target or outcome is whether this person make a purchase within the given time window or not. Based on the historical purchase data, we will need to build features which describe each data point such as user age, address, last purchase day, and then supervised learning algorithms will learn from this data how to map these features to the prediction target or outcome. The second one is unsupervised learning algorithms. So unlike supervised learning algorithms, unsupervised learning algorithms are used when we do not have a specific prediction target or outcome. This type of machine learning algorithm is frequently used in clustering and recommendation system. As an example, you can use an unsupervised learning algorithm to cluster your customer base into different subgroups or segments based on their behaviors. In this case, we do not have a specific target or outcome that we want to predict. We are just grouping similar customers together into different segments. We were exploring how to use unsupervised learning algorithms in marketing in a later section. And the last one is reinforcement learning algorithms. These algorithms are used when we want to model the tool continuously learn and train itself without prior knowledge or experience. So in this case of reinforcement learning, the model learns how to make predictions after lots of trial and errors. One example of the application of reinforcement learning in marketing is when there are multiple marketing strategies you would like to test and choose the one that works the best. In this case, you can run the reinforcement learning algorithm where it randomly pick one strategy at a time and get rewarded when a positive outcome occurs. After multiple iterations of trials and error, the reinforcement learning model will have learned to choose the best marketing strategy based on the total rewards each marketing strategy has learned. Now let's talk about the data science workflow. The first one is a problem definition. A typical any data science and machine learning problem start with a problem definition. In this first step, you need to define the problems that you are trying to solve with data science, the scope of the project, and the approaches to solving this problem. When you are thinking about some of the approaches to solving your problem, you need to brainstorm on what type of analysis, which is descriptive versus exploratory versus predictive, and type of learning algorithms, which can be supervised learning versus unsupervised and reinforcement learning. That we discussed previously will be suitable for solving the given problem. The second one is data collection. So when you have a clear definition of the project, you will then move on to the data collection step. This is where you gather all the data that you need to proceed with your data science project. It is not uncommon that you will need to purchase data from the third-party vendors, scrape or extract data from the web, or use publicly available data. In some cases, you will also need to collect data from your internal system for your projects. Depending on the cases, the data collection step can be trivial or it can also be tedious. The third one is the data preparation. So when you have gathered all of the data you need from the data collection step, then the next step is data preparation. So the goal of this step is to transform your data and prepare it for your future step. If the formats of the data sources are different, you then you will have to transform and unify the data. If the data doesn't have a certain structure, then you have to structure the data typically in tabular format so that you will easily conduct different analysis and build a machine learning model. The next one is data analysis. So when you are done with data preparation step, then you will have to start looking into the data. In the data analysis step, typically descriptive analyses are conducted to compute more descriptive summary statistics and build visual plots to better understand the data. Quite often, you can find some recognizable patterns and draw some insights from the data during this step. You may also be able to find any anomalies in the data, such as missing values, corrupted data, and duplicate records from this step. The next step is feature engineering. So feature engineering is the most important part of data science and machine learning, as it directly affects the performance of predictive models. Feature engineering requires expertise and good domain knowledge of the data, as it requires you to transform the raw data into more informative data for your algorithms to learn from. One good example of feature engineering is transforming text data into numerical data. As the machine learning algorithm can only learn from the numerical data, you will need to come up with an idea or and strategy to translate textual data into numerical data. As we work through this course, we will build a machine learning models and we will discuss and experiment with various feature engineering techniques. The next one is model building. Model building. So once you are done with your feature engineering step, then you can start training and testing your machine learning model. In this step, you can experiment with various learning algorithms to figure out which one works the best for your use case. One thing to keep in mind in this step is the validation matrix. It is important to have good measure of your model performance, as machine learning algorithm will try to optimize on the given performance measure. As we start building machine learning models in the following sections, we will discuss more detail regarding what metrics to use depending on the type of problems that we are working on. So this is a typical workflow for data science. So first you will have the problem definition and then you collect the data. After that you will prepare the data, analyze data, we will perform feature engineering, and finally we'll do the building model. And then if you want to improve the results, we repeat the step from the data collection again. So we will collect more data here and then we will do prepare the data, analyze the data, feature engineering, and we build another model. So as can you see from this diagram, quite often the data science work does not end in one iteration. You may have to repeat the data collection step when you notice that the model is not performing well. And when you notice you can improve on the quality of the input data. You may have to revisit the feature engineering step when you come up with the better ideas and strategies on building the features from the raw dataset. You also may have to repeat the model step more than once if you think you can improve the model results by tuning the hyperparameters of the machine learning models. I mean the learning algorithms. As we work through the following sections, and as we work on the actual projects and exercise in this course, we are going to discuss in more detail certain steps and different techniques we can use. And that is all in this video. So I hope you enjoy it and I will see you in the next video.